Okay, folks, we're now on page 8, and we're solving some inequality problems. So let's start off with problem B to start with, because we'll work with an inequality, and then we'll go back to, we'll work with an equation, and then we'll go back and work with an inequality. On this first part, you basically, algebraically speaking, you have two equations whenever you have an absolute value equation. So you have 5x minus 2. You want to see when that's equal to 8. But you also have to consider the case where you have 5x minus 2 is equal to negative 8. So we have to solve for both situations, because the absolute value basically incorporates both ideas, when it equals 8 and when that 5x minus 2 will be equal to negative 8, because when we absolute value that, we'll also get 8. So we've got to look for both answers. So here we have 5x. That's equal to 10, and x is equal to 2. And on this one we have 5x is equal to negative 6, or x is equal to negative 6 over 5. So in both situations we should get that equal to 8 if we plug in both solutions. And when we plug them both in, we do get 8. And I don't want to demonstrate that, but if I take negative 6/5 and multiply by 5, I get negative 6. Minus 2 gives me negative 8. Absolute value gives me 8. So I just want to check that quickly, make sure it made sense. So I'm going to shrink that, and I'm going to work on the inequality, which has a little bit different of a step, but it's not such a big deal. I'll just miniaturize that for a moment. Let's work on this part. So here we have two absolute value equations, or two equations, inequalities we have to solve. We have the first one where we have negative x plus 4 is less than or equal to 1. That's as if we just had the positive quantity coming out from the inequality. Now when we do the next part, we have negative x plus 4. Now I've got to switch the sign because I'm multiplying that by negative 1, so I've got to switch the inequality. So I put negative 1, I change the direction, and now I go about and solve both of these equations, just like I would any other inequality. I have negative x plus 4 is less than or equal, that looks just like the same step. Negative x is less than or equal to negative 3. And now x, because I'm going to divide by negative 1, is going to be greater than or equal to 3. On this one, I have negative x is greater than or equal to negative 5. Or I'm going to have x is less than or equal to 5. So basically the solution set for this on a number line would be all the values included would satisfy this from 3 to 5. So hopefully that makes sense to you. I have another way for you to think of this when I see you in class. If you have trouble with this, I could help you out after school with the inequality problems. So anyway, on part C, let me just pause for a minute. Okay, so here we have this third inequality. Not inequality, third absolute value equation that we want to solve. And we'll write it up. We have two things to solve. We basically have the positive part, 2x plus 1 is equal to positive x plus 3, and then we have the other equation, 2x plus 1 is equal to negative of x plus 3. Okay, so when we solve this part, we just get an answer. We subtract x from both sides, we get 1x on the left, and we subtract 1 from both sides, and we get 2. So x equals 2. If we check that, you plug 2 into here, you get 5, and you plug 2 into the other side, you get 5, so that checks. On the next one, we get a bit of a fractional answer, so we have 2x plus 1 equals negative x minus 3. Distribute the negative, add x over, you get 3x from both sides. Subtract 1 from both sides, you get negative 4. So my answer here is negative 4/3. And upon checking that, when I plug negative 4/3 in, I got 2 times negative 4/3 plus 1. Absolute value of that, the absolute value of that, that's correct, sorry, is going to be, this will make negative 8/3 plus 1. That will be negative 5/3 when you add them, and then when you absolute value, you'll get 5/3. And then when you take negative 4/3 and you plug it into that, you'll get a negative 4/3 plus 3. you'll switch the 3 to 9/3, and you'll end up getting positive 5/3 as well. So they both check out as solutions, and that's basically how you would solve those absolute value equations. Remember, the big component is the absolute value has two parts to it. There's a part where the one, when you take away the absolute value brackets, you've got the positive component and the negative component that you've got to worry about. So anyway, on the next one, it says determine the equation through the lines, through the following. Determine the equations of the following lines. So we have 2 points. So the first thing you want to do is to find the equation of the line. You can find the slope first, and then you could put it into, and you can use 1 point and put it into point slope form. And I think that would be the best thing to do for most of the work we do in AP Calc, is your ability to calculate slope quickly and use the point slope form to find the equation y minus y1 equals the slope times x minus x1. That would be the most beneficial equation that you could use, especially when we're doing tangent line equations in the course. So what we do first when we calculate slope, you have to remember you should just remember it's change in y over change in x. So the change in the y coordinates changing, and what I do to show people this visually is I just take the coordinates and I put them on top of each other, and I just look at the y coordinates and I say, okay, how much do they change by? You subtract them, 7. How much did the x coordinates change by? -3. So your slope is -7/3, and then I put them into my point slope form, just using a point. Y minus, I pick a point, so I'll use the first point. You could use the second point, but for this equation right here, I'm using the first point. And I'll use the corresponding x coordinate, and that would be my equation in point slope form. The next one says to find an equation perpendicular to this line that's in standard form. So what we want to do is I'm just going to set up my equation. Y minus, this is my y1, is equal to my perpendicular slope x minus x1. So that's the start for my equation, but this has got to be perpendicular to this line. So I'm going to just solve this equation. -3y equals -2x minus 5, and when I divide by 3, I'll get positive 2/3 x plus 5/3. So that's what I'm interested in. That's my slope. If I'm going to be parallel, that will be my slope for a parallel line. But I want to change that to the opposite reciprocal. So I'm going to just rewrite this as y minus 2 equals -3/2 x plus 1. That would be my equation of a line going through that one point perpendicular to the other equation. Okay, so now it asks me for the equation of a line through that point going through the midpoint of the line segment from these 2 points. So this is just, again, checking to make sure we understand what a midpoint is between 2 points. Midpoint is the average of the coordinates. So when we do the average of the coordinates, I'm going to average the x coordinates, and -1 plus 3 is 2. 2 divided by 2 is 1. So the average of the x coordinates would be 1, and the average of the y coordinates is between 4 and 2, so it's got to be 3. So that's my point, my midpoint of that line segment. So now to write up the equation, I have 2 points. I have 2, 3 for the first point, and I have 1, 3 for the second point. And so when we do a slope calculation, remember I just stack the points, 2, 3, 1, 3, to look at my change in y. My change in y will be 0. My change in x will be 1. So my slope is going to be 0 over 1. That means that my line is horizontal, so I could use either this point or this point, but I'm basically going to have y minus 3 is equal to a 0 slope, x minus 2 if I'm using that point. And what this results in is just an equation of a horizontal line of y equals 3. That's it for this segment. We've gone over 10 minutes. Page 8 done. Next page we'll be working on in a couple minutes. Hopefully you have time to look at that.